Hello and good evening, and welcome to part 3 in this 4-part series on OSPF stub areas. This is the third video, and we're going to be talking about the OSPF Not-So-Stubby Area, or it's commonly referred to as an NSSA. And so in our first two videos, we took a look at the OSPF stub area and the OSPF totally stubby area. And we saw that the major difference between the two was in a totally stubby area. Make a little note down here. So in a totally stubby area, there were no type 3, type 4, or type 5, and I'll put type 7 in here. We're going to demonstrate that in a second. And no type 7s allowed, right? And in a stub area, there were no type 4, type 5, or type 7s allowed. And again, we're going to see this here in a second. I'm going to demonstrate what happens when you try to redistribute an external route, right, or an external prefix that is not in the OSPF domain into an OSPF stub area. So the stub says there's no type 4, type 5, or type 7. The totally stub says no type 3, type 4, type 7, 3, 4, 5, and 7. So the big question becomes, and you'll notice here from the diagram, it's changed a little bit, right? We've got external networking sources all over this area, right? So what we're going to have happen is that these routers are going to become ASBRs. And that stands for Autonomous System Boundary Router. Sometimes you'll see it referred to as Autonomous System Border Router. And all that means is that it is injecting external routing information from outside of the OSPF domain into the OSPF domain, right? So this external network is going to get redistributed, and basically the way that this is set up, very simple, right? These are simply loopback addresses. This is loopback 172, and then under the OSPF section, I'm simply redistributing connected. Same thing over here. This is loopback 209 and loopback address 192. All right, so now we're going to take a look at the Not-So-Stubby area. Okay, and so what is the major difference? Well, the first major difference is in NSSA, you can have external routing information in an NSSA, right? So external routes allowed. Now remember, external routes that have been redistributed into the EIGRP process are not allowed with a stub or a totally stubby area. So let's take a look at that first. Let's go ahead and prove that to be true on router 3 if I say show IP route. And let's take a look at the information that we're seeing here. So I've got my 3 inter-area prefixes, right? And then no external prefixes. And let me take a look here, show run section OSPF real quick. And that is not supposed to be set up yet. So let me jump in here, router OSPF 1, no area 1 NSSA. And I'm assuming that that is also going to be on router 1 here. I apologize. Do show run section OSPF. Yes, router OSPF, we got to get that off of there. Router OSPF 1. No area 1 in SSA. All right, so now that we've got that off of there, let's take a look at the routing table now. Do show IP route. All right, and that's what I had expected to see because I was looking for these externals. So as you can see here, so we're back on router 3. Router 3 is seeing 2 type 5 external routes. The first one is the 192.168.100, which is being advertised here by router 6. And then the second one is the 209.165.100, which is being advertised by router 4. So as you can clearly see, and right now, remember, again, we don't have any stub areas. This is just simply multi-area OSPF. We have not done any configuration work to make an area a stub area or a totally stubby area or a not-so-stubby area at this point. Let's see what router 1's view of the network looks like. So router 1 should also see the 172.16.100. Again, remember, right now we're redistributing this external route into OSPF, and so router 1 here, who is an ABR, he actually sees this information, right? Just like the rest of the routers that are out here. Let's take a look at router 7. Router 7 should also see 3 external routes. He sees the 172, he sees the 192, and he sees the 209, right? And again, these are type 5 LSAs right now, and they are being redistributed simply into OSPF areas, right? Okay, so now let's go back to router 3. Let's go back to the topic of, with a stub area or a totally stubby area, remember we said you can't have type 7s in those areas. And the reason being is because you can't have the ASBR also be set up as a stub. And that's where the NSSA comes in. So let me go ahead and say let's say area 1 stub. And we're going to receive an error message here that's going to indicate, and there it is right there. As soon as I try to set that as a stub, take a look at what happened. OSPF ASBR without valid area. Router is currently an ASBR. Now, why is it an ASBR? So it's an autonomous system boundary router because we are redistributing external routing information using this router, and therefore it's seen as an ASBR. If I were to say do show IP protocols, right, we can see that we've got the listing here for, where are we at here? For routing protocol OSPF 1, and what does it say about the router with the router ID 3.3.3.3? It is an autonomous system boundary router, right? And it says redistributing external routes from, and again, it's just a loopback address, so connected, and includes subnets in the redistribution. So we are an autonomous system boundary router. Therefore, as a stub or a totally stub, right? Remember, the configuration that we've put on here is just simply area 1 stub. So if on router 1 I were to say area 1 stub or area 1 stub no summary, that doesn't change the fact that router 3 still believes that he is an ASBR, because an autonomous system boundary router by definition is a router within OSPF that is redistributing external routes into the OSPF routing domain. And that's exactly what router 3 is doing here. If I were to say do show run section OSPF, whoops, you can see that there's my redistribute connected subnets command. And I've put on here area 1 stub. Well, let's go ahead. Let's configure the other side, because maybe you're saying, well, you know what? What if you configure router 1 and say area 1 stub? Is that going to bring the adjacency back up? Is that going to allow the routing information to be seen? So as you can see here, our adjacency has come back up. So if I say do show run section, do show run, what do we want to see here? Do show IP OSPF, neighbors. You can see that my adjacency is established with router 3 again, right? So router 1 sees router 3 as a neighbor. However, on router 1, when I say, excuse me, do show IP route, I no longer see the 172.16, right? I'm not seeing this network that we're redistributing via router 3 into the OSPF domain. So what does router 3 see? Do show IP OSPF neighbor. My only neighbor is router 1. My adjacency is up. Do show IP route. I'm a stub, so by definition, a stub is going to get what? Auto-magically, I'm going to pick up a default route here as a type 3 inter area, right? And remember, I'm not totally stubby. Totally stubby would wipe out these other type 3 inner area advertisements. I'm just a stub, right? So I still see these, but what don't we see? I don't see the type 5s that would be the external networks from router 4 and router 6, right? Because remember, stub does not allow type 4, type 5, or type 7s. And the type 7, if I were to say do show IP OSPF database, excuse me, if I were to, when we make this an NSSA, a not-so-stubby area, you're going to see that we're going to have an OSPF database entry that is a type 7 LSA that represents two things. The first thing it represents is that router 3 is an ASBR, and the second thing it represents is the external networks, in our case just this one, 172.16.100. The type 7 LSA is going to represent the external network that is being redistributed into the OSPF domain. And then there's going to be a conversion that takes place, and we're going to talk about that in a second. So as you can clearly see, right, let me come all the way over here to router 4. What does router 4 see now? Does router 4 still see the 172.16.100? He doesn't. It's gone. What about router 6 down at the bottom of our diagram there? Now these guys saw that 172.16 before, and now that route is gone. And so this is what I meant when I said a stub, you are not going to see a type 7 in a stub area. Because in order to get a type 7, you have to redistribute an external routing source into the OSPF domain. And a stub does not support that, and we saw the error message. So what about totally stubby? All right, that's easy enough to set up here. Let's go back, and we're going to say no area 1 stub, and I'm going to say area 1 stub, no summary, right? Because that's the command required at the ABR in order to set things up as a totally stubby area. So do show IP OSPF database. Wait, the adjacency just came back up there. So I'll run it again just to be sure, right? But again, we see the router link states, right? We see our type 1 LSAs. I see my type 3 LSAs. Remember, there's no type 2s here because it's not a multi-access segment, right? It's a point-to-point serial connection. But again, I don't see anything in the OSPF database representative of that external network which is being redistributed into OSPF. So let me come over to router 1. Did this change anything from router 1's perspective? If I say do show IP route, do I see that 172? I don't. It's still not there, right? Okay, so we've done our due diligence here. We've confirmed, do show IP route, we've confirmed that irrespective of whether it's a stub or a totally stub, I cannot redistribute external routing information into the OSPF process when I'm set up as a stub or a total stub. And as you can see here, right, we did a total stub, so now my type 3s are gone, right? If I say do show IP OSPF database, just to confirm, all we have is that type 3 default, the exception, which is the type 3 inter-area LSA for our default route, so that we can get out of our local network segment here out to router 1, and our two type 1 router link states for router 1 and router 3. All right, so the first big difference with the NSSA, the not-so-stubby area, is that external routes are allowed, right? So let's go ahead and let's change. And before we do that, let's do one last look over here, and let's make sure that 172 is not there, right? There is no 172. And so that's being suppressed right now by OSPF because OSPF recognizes the fact that it is a stub or a totally stub, and type 7s are not going to be allowed. So let's convert this to a not-so-stubby area. And what I'm saying here is I've got a requirement of some kind where, one, I need to be part of the OSPF domain, and two, I have external routing information that I need to redistribute into OSPF that is external to the OSPF domain. So we're going to go ahead and say no area. So no area 1 stub, and instead I'm going to say area 1 NSSA. Right? So I'm going to come over here to router 1 because we're going to need to do the same thing. No area 1 stub, and then we're going to say area 1 NSSA. Whoops, NSSA. Now let's see what happens here. It's going to take a couple seconds for the adjacency to come back up. It looks like we're good. So I'm going to say do show IP route. Let's take a look at the routing table. And you can see as a not-so-stubby area, what did not happen auto-magically that did take place when we were doing the stub and the totally stub. And in looking at the routing table, you can see there's one glaring omission here. The second major difference, right? The first major difference is external routing information is allowed to be redistributed into the OSPF Not-So-Stubby area. The second major difference here is that there is no default route. That's, and I'll put automatic because we're going to go ahead. You can set it up and we're going to do that. So there is no automatic injection or injection of a default route in a not-so-stubby area. So if my requirement was I need to be part of the OSPF domain and I need to be able to redistribute external routing source information into OSPF, and I don't care if I get a default route or not, then I would be looking at a not-so-stubby area for that use case, right? So let's walk through these, the three that we've talked about so far. So a stub, if my requirement is I have one way out of the network and I'm okay getting inter-area routes, type 3s, and I automatically want to receive a default route, then I would want to look at setting that area up as a stub. For a totally stub, the use case is if I don't want any type 3, 4, 5, or 7, right? And all I want is a default route automatically sent to me as a type 3 because I only have one way out of the network, then I would want to be a totally stub. And a totally stub is just saying, hey, you know what? I'm not interested in all the type 3 summary LSAs. I don't care about that stuff, right? I don't care about the externals. And obviously we just saw you're not going to see type 7s anyway because it wouldn't be a totally stub if you were trying to get type 7s in there. And again, in both of these cases here, stub and totally stub, I don't want to redistribute any external networks into the OSPF routing domain. If your use case is, hey, I do need to redistribute external routing sources into OSPF, and I don't care whether or not I get a default route, and I've got a single path out of the network. And again, you could have more than one path out. It's not saying that you can only have one out, but you could have multiple. But in this use case right here that we're looking at, if you need to redistribute external routing information, the not-so-stubby area is going to be the way to go. All right, so we've set up an NSSA, and you can see that what else is taking place here. So let's talk about with the NSSA, right, what kind of routing sources are prohibited. So just like the stub and the totally stub, the NSSA says no type 5 and no type 4s will be allowed in from the ABR. So this is our ABR here, right? So let's label this guy as our ABR. He's our area border router because by definition, he has an interface in area 0 and one or more interfaces in a non-area 0 area. And in this case, we know it's area 1. So he's our ABR. So when type 5 information shows up here or type 4 information shows up here, because we've set this up as an NSSA, that information is not going to be injected into Area 1 because this is a not-so-stubby area. So, by default, when we talk about the not-so-stubby area, it's going to allow in inter-area type 3 LSAs only, right? From outside, from the ABR. So type 5s are being blocked. Type 4s are not going to be injected, right? And you'll notice we don't get the auto-magic default route out. So again, definitely something to consider. If you need to get external information in, it's going to have to be an NSSA area because stub and totally stub are not going to allow you to do that. So let's take a look at our database. So do show IP OSPF database. All right, now remember before we did not see a type 7. Now we do see a type 7. And you can see here, type 7 AS external link state for that network ID. Who's the advertising router? So who's the router that's redistributing that information into the OSPF domain? It's router 3. Right? So what does router 1 see? Because he's not the router that's redistributing that information into the OSPF domain. So do show IP route. And does he see anything for that 172? He does. And this is a very key point right here. Is remember, router 1 is in area 1, right? So he has an interface that's a member of Area 1, so he will see that route as a Type 7 route. And that's what the N, right? Think of it for NSSA, that's what the N represents. If I say do show IP OSPF database, we have a few more routes here. We've got a lot more information there. So here is the type 7 link state entry into the database for area 1, and it's the 172.16.100.0, right? So it's that route that's being redistributed into OSPF. Now, because it's an NSSA, we can do this redistribution. And when I say do show IP route, because router 1 has an interface that is a member of area 0, he sees that route as a type 7 route, and that's what the N is going to represent, right? If it was a type 5, it would have an E. Because remember, these two loopbacks here, right, those loopbacks are just simply being redistributed. There's no stub area, there's no totally stub, there's no NSSA. It's just seen as a type 5, right? This designator here, N2, which is the default for a type 7, N2, that's how router 1 is going to see this route. Now, he's participating in area 1. Let's go over to router 4 and see what happens. When I say show IP route, what does router 4 see? Now, this is interesting. So router 4 doesn't see the route as an N2. He doesn't see it as a type 7. He sees it as a type 5. How about his OSPF database? Does he have any type 7 LSAs here? He doesn't. In fact, he sees that 172.16 being advertised from the ABR 1111. He sees it as a type 5. So what is it that's taking place between area 1, where everyone in here is seeing that route as a type 7, right? As an N2 type 7. However, and if we were to go to router 6, we're going to see the same thing. So I'll quickly go ahead and say show IP route. And you're going to see that it's also external there, show IP OSPF database. It's seen as a type 5. So everybody else outside of this not-so-stubby area here is not seeing that as a type 7. They're all seeing that 172.16 as a type 5. And here's what takes place. The route gets redistributed into the OSPF process. The ASBR, the Autonomous System Boundary Router, then sends the type 7 LSA over to the ABR, who is in the same area, who has an interface in that same area, and the ABR says, I'm going to go ahead and convert that type 7 LSA into a type 5 LSA. And so it goes out as a type 5, right? And for all type 7s in this area, if I were to create a bunch of loopback addresses and continue to redistribute those loopback addresses into OSPF from the external source, right? Okay, because these routes are not originating in OSPF. So on that loopback interface, and if we take a look, you'll see there is no do show run interface loopback 172. There is no IP OSPF 1 area 1 statement here. If I were to do that, I would be originating that route as part of the OSPF domain, but we are not. We are redistributing this route. And again, routing sources, it could be a connected, it could be a static, it could be a BGP route, but the key is it's external to the OSPF domain, right? And the ABR's job, which is router 1 here, his job is to make sure that for type 7s that he gets, he is going to go ahead and flood a type 5 LSA for those routes. Now, remember I mentioned prior to this that for this use case that we have here, obviously we've got one way out of the network, right? And so that's a great use case. So what if I had another router here, let's just call this router 9, and let's say router 9 has an interface into the backbone, and let's say that maybe he's connected up here to serial 010 for whatever reason, right? So now the ASBR router 3, he has 2 paths out of the network. So the LSA will be flooded to both ABRs. The type 7 LSA for this external network is going to be flooded to both of these ABRs, because router 9 would also be an ABR, right? Because he has one or more interfaces participating in area 0. I'm sorry, he has an interface participating in area 0 and one or more interfaces in another non-area 0 area. So he's an ABR as well. So that type 7 LSA gets flooded to 9, it gets flooded to 1, and then the question becomes who will flood or who will do the conversion, the type 7 to type 5 conversion. How is that decided? And it's very simple. It's going to be the highest router ID. So the highest router ID does your type 7 to type 5 conversion. And following our setup here, the router IDs are basically just the router number in IP, and what am I trying to say? In the dotted decimal format, so 11117777. So staying with that, if this was 9999, and that type 7 LSA shows up at both these ABRs here, which ABR is going to take responsibility for flooding or doing the conversion from 7 to 5 and then flooding that information out to the backbone area so it can be shared with the rest of the OSPF domain. And it's going to be router 9 because he has a higher router ID. All right, so let's wrap this up with the last little key thing here. If I come back over to router 3 and we say do show IP route, you'll remember that with the stub area and the totally stubby area, we conveniently were provided with a default route, right? So it auto-magically happened. It was a type 3 LSA, so an inter-area route was automatically provided to, default route was automatically provided to us. So here, I only know, and I can only get to the information that I know about. So if I were to say do ping, and the way that these loopbacks are set up, 209.165.100.4 is the last octet is simply the router number. So if I say do ping 209.165.100.4, do I have any reachability to get there? Well, the gateway of last resort is not set. Okay, remember, I'm a not-so-stubby area. There's no oops, sorry about that. Let's stretch that back out. Where did it go? There we go. There is no default route here. So if it's not in my routing table, I do not know how to get there, right? So I can hit these transit networks. So let's go ahead and see if we can do ping 10.10.47. And that's going to be, I can do 47.7. I can do 47.4, right? So I can reach those networks because I have routes to, and those are transit networks, I have routes to get to those transit networks. So that's going to work just fine. But let's say that I need to make sure that I can get out of this network even though I only have one way out. I want to make sure I get a default route provided to me. So how does that work? Well, just like you do the default information originate when you set up in your OSPF domain under the router OSPF process, it's the exact same thing, right? And this configuration is going to get done on the ABR because, again, the ABR is the one who would inject that routing information to say, hey, if you don't know how to get out of, let's do the show run section OSPF. The ABR is going to say, if you don't know how to get out of off this network segment, then use me as your default route. And so that's what we're going to do here. So you can see we have the Area 1 NSSA, and we're also going to go ahead and add in, and I'll do a question mark, and you can see default information originate. And what kind of a default route are we going to originate? You got it. It's going to be a type 7. So before we even do this, if I were to ask you, is it going to show up as an OIA? Is it going to show up as just an O, right? So intra-area route? Is it going to show up as an OIA and inter-area route? Or are we going to see this as an OE2 for an external route? Or will it be an N2 representing a type 7 default route? Type 7 LSA default route. So let's take a look. So I've added it in there, the Area 1 NSSA default information originate. Let's come back over here to router 3, and we're not going to ping. I'm going to go ahead and do a do show IP route, and you guessed it. So by default, the NSSA does not provide you with a default route. You can certainly configure it, and we just did. And another key thing to note here is that the not-so-stubby area, when you do the default information originate, it's going to inject that as a type 7 LSA. So again, if I were to say do show IP OSPF database, we should now have 2 type 7 LSAs in our database, and we do. We've got our default route, and we have the redistributed external route that is actually just a loopback address, but again, it's not part of the OSPF routing domain. It is external to the OSPF routing domain, and therefore it's going to be seen as a type 7 AS external route. All right, so that pretty much wraps up the not-so-stubby area. Let's take a look here on the far end, and let's confirm. You can see that 172, right? It's seen as a type 5. And so the major highlights here, just to reiterate, right? The first thing is with a not-so-stubby area, right? With an NSSA area, I can have external routes. We saw that. We also saw that with a stub and a totally stub, there is no way we're getting type 7s in there. OSPF will automatically give you an error message and tell you, hey, listen, you can't redistribute external routing sources into a stub area or into a totally stubby area. So we're not going to see type 7s in there. So the first thing with the NSSA, we can use external routing information in the area. The second key factor is that if you need a default route, you're going to have to type in, or you're going to have to add that in manually with the default information originate statement. And then the third major thing that happens, and I'll squeeze this in here, is that at the ABR, the type 7 is going to be converted into a type 5 LSA. And the type 5 LSA is what's going to be sent out to the rest of the OSPF domain. And the reason for that, there's an important reason for that, or how that happens, is remember, type 5 LSAs, external LSAs, have domain scope, which means they will go all throughout the OSPF domain. And as we saw, right, the type 5 LSA, once it's converted, it showed up over here on router 6, right? We showed up here, we showed up there, it showed up here, it showed up here, and this is area 2, this is area 3. So they have domain-wide scope, type 5 LSAs. So the conversion takes place at the ABR. It goes from a type 7 to a type 5, and then that gets shared to all of the other areas that we have here in our setup. All right, so that wraps up the Not-So-Stubby area and the third of 4 videos. The final video that we're going to do is going to be the totally Not-So-Stubby area. And we'll talk a little bit about the fact that the totally stub and the totally not-so-stubby area, the word totally will be a huge clue for you to remember the differences. And now, real quickly, if you're interested, RFC 3101 covers the not-so-stubby area. And one of the things that I wanted to touch on here in the RFC is if you look for the E-bit again. Remember we talked about the E-bit for a stub area. Well, it just so happens that the NSSA has what's called the N bit. And what does that N bit do? It ensures that all members of an NSSA agree on the area's configuration. And now these are inextricably linked here. So the N bit and the E bit reflect an interfaces, and consequently the interfaces associated area, external LSA flooding capability. So as explained in 10.5, if type 5 LSAs are not flooded into or throughout the area, the E-bit's got to be clear in the option field of the receive hello packets. And we saw that in the first video where we took a look at the stub, OSPF stub areas. So type 5 LSAs on that interface, interfaces associated with the NSSA will not send or receive type 5 LSAs on that interface, but may send and receive type 7 LSAs. Therefore, if the N bit is set in the option field, the E bit must be clear. And remember, when we looked at the stub and the totally stub, in the hello packets, the E bit cannot be set. It has to be clear. In just a regular area, multi-area OSPF setup, right? And let's say that none of these are stubs or totally stubs or NSSAs or anything. The E bit is set. As soon as I make it a stub area, right? In the hello packets, the E bit has to be clear. And so this makes really good sense. If the N bit is set, meaning that we have declared this an NSSA area, can we have the E bit set as well? No, we can't. It's impossible, right? So the E bit can't be set because that indicates that it's a stub area. And in a not-so-stubby area, we're going to have the N bit set, and that's what's going to allow us to get that type 7 information into that external routing information into the OSPF area, in the OSPF domain, right? So again, RFC 3101, right, covers the OSPF Not-So-Stubby Area option. All right, hopefully this is, again, continuing to build for you and clear up a lot of the confusion that new learners have with the differences of the areas, which LSAs are allowed, which LSAs aren't allowed, why are they allowed, why aren't they allowed, and how come that Type 7 pops out of the Area 1 ABR as a Type 5. All right, thanks for watching, and hopefully I will see you at the totally not so stubby area video. Have a great evening.